We got 1 minute. Trying to work out the safest place to put this.
You don't have the presentation here.
No, it's there.
You click the YouTube thing.
Cool. All right, let's get this started. The door's going to shut. Excellent. Hi, everyone. My name is Mark Mandel. I am a developer advocate for Google Cloud Platform.
And I'm Gustavo Ambrozio. I'm the lead developer for War Dragons at Pocket Gems.
Welcome to Scaling Mobile Games to a Global Audience using App Engine and Cloud Datastore, possibly the longest title here at this event. You could probably also rename this as Building Games Without DevOps. Would probably be quite appropriate as well. So, what are we going to talk about today? Well, we're going to talk about a game called War Dragons. And thanks, Gustavo, so much for coming by today to talk to us about that. We really appreciate it. So we're going to go through what that game is, have a look at it. It's pretty awesome. I like it a lot. We're going to look at how its back-end infrastructure works, right? So obviously, this is a cloud event. We want to look at back-end infrastructure. We want to see what's going on there. We're going to talk about what worked well. What were the success stories? What were the great things that happened? And we're also going to look at some of the problems they faced. What lessons have been learned? What can we teach you about building back-end infrastructures for this sort of application? Finally, we'll put a bow on it, reach a nice conclusion, and that will be the end of the session. Sound good?
Sounds awesome.
Excellent. So let's get started. War Dragons. It's a great game. I've played it. I really enjoy it. Gustavo, do you want to tell us a little bit more about what the game's all about?
Sure thing. So War Dragons is our highly polished 3D real-time strategy mobile game where you get to collect and control hundreds of dragons to take out enemy bases. In short, you get to control a lot of very awesome looking dragons and blow up a lot of stuff. It was Pocket Gem's first 3D game. It was our first game to have synchronous real-time multiplayer battles, and our first game to come out like on day one with a lot of social features. So features such as guilds, multiple chat rooms, leaderboards, wars, and much more. So you can see that in that respect, it was one game that put a lot more pressure on our servers than any other games that we had before.
Thanks for that. So the first question I have for you is, why did you build a multiplayer game? You could have built a game that was just on a mobile device, no interconnectivity, but you decided to build a game where people could battle each other and there was a back end and all that sort of stuff. What was the deal there?
So when we started developing War Dragons 2 years ago, we saw an opportunity to build something that nobody has built before on mobile. So there were a lot of games out there where you can battle other people's bases, but it was always asynchronous, like somebody can attack your base, but you cannot defend yourself as they are attacking you. There was nothing like that on the market at that point, and we saw that opportunity, and we knew that we can build something like that. We also saw the opportunity to build something in 3D, which we also never did before. We saw that the market was right, and the devices were right for that at that moment.
Now, hold on just a second. Is that you over on the right-hand side there?
Oh, yeah, that third character, thank you for recognizing it. Thank you for seeing the resemblance. That's Lord Gustavo, that inspired by me, obviously. I think you guys can see the resemblance. If you guys play War Dragons, you're going to see Lord Gustavo. I'm the main villain of the game, obviously, as well.
Wonderful. OK, so this game of yours seems to have been reasonably popular.
Yeah, it's been really popular. This is a graph to represent that. So this is the number of battles per day that we had since we launched. So you see that first beginning there is right before we launch. When we launch, you get that big spike, getting a bunch of users. After a few months, we got featured by Apple, so we get that other big spike over there. That last spike that came down was a special event that we had where people could battle unlimited number of battles. There was no waiting time, so people did a lot of battles during that weekend. And like the interesting thing about this is that with all those spikes, with all that variation, we never had any meetings to say what's going to be this impacts in our infrastructure and how are we going to handle millions of users when we had none so far, and our server's going to explode and we're going to have to like run around like crazy trying to fix our infrastructure. We never had any of that. Whenever we had those spikes, nobody had to like call anybody else and come fix our servers because things are exploding. We never had any of that throughout all of those things. Like our infrastructure just worked throughout all this period of time. Just so you guys have an idea, this is like War Dragon's been out for roughly a year now, and these number of battles add up to 180 million battles already. So just so you have an idea of the scale of this.
Excellent. OK, so let's talk a little bit about how it works. What's the back-end infrastructure look like, and what's it powered by? I know when you and I first got together, we talked about how the primary part of the back-end infrastructure is powered by App Engine and Datastore. Can you tell me about the history there, how you came to use these two products, the decision that drove you to do those things?
Sure. So this decision was a little bit before my time at Pocket Gems. But basically, the story is Pocket Gems started as two guys had an idea for a mobile game and started building that mobile game, right? So there were two guys that knew how to build mobile games, but they didn't know anything about server infrastructure, even how to code for servers. And at some point, they figured, like, we need servers. We need servers to collect data from our users. We need servers to make our users do stuff together. So they figured that, and they started to look for a solution to their problem, right? So they started researching out there for a solution to their problem. And one of the things that they bumped into was Google App Engine. There were the first few tutorials out there for Google App Engine. They started to do the tutorials and try it out. It was free to try it out. They were also pretty much broke at that time. They were spending all their money in marketing for the game. But Google App Engine fitted the requirements. It was easy to use, so they started building with that, right? So it was kind of like a knee-jerk reaction. But throughout this 6 years of Pocket Gems, like, we never had a doubt that that was the right solution. As I said, we never had trouble with like servers exploding, people running around trying to fix because our users couldn't play the game, right? We never had a DevOps team. Like, we don't have people around like 24/7 because things can explode and you have to get to the office and fix things. So it paid off to us. Like, we sometimes revisit the decision to see if there's something better out there, but so far nothing jumped out. Like, it's been a good solution for us. When we started War Dragons, we didn't even think about that. That was not an issue at that point.
So it's kind of something you kind of fell into, but it's been so consistent and easy to use that you've just stayed with it all the way through.
Yeah, it was the right decision, even though like it was a knee-jerk reaction, but it was the right decision. It paid off.
Excellent. So just to set like the stable set of context so we all have the same understanding, hands up the people here who have worked with App Engine or are familiar with it. OK, about half the room. How many people here have used Datastore or are familiar with it? OK, again, about half the room. Great, that's perfect. So I'm just going to go through some very quick introductory parts for these products so that we sort of have the same understanding. These products are what I like to refer to as managed products. What does that necessarily mean, though? What it means, and I think to me and to many other people, is it's the very direct opposite of this. I know I've done this in the past. I'm sure many of you have too, where you're like, all right, I think I'm going to get this much load in, so I think I'll need 4 web servers and maybe a database replication and maybe some other servers to do some other things. And this might be physical, this might be virtual, but this is really kind of no fun, right? You're managing your own scale, you're managing your own machines. It's not really great. When we talk about Google Cloud Platform services and managed services, what we really want to be able to say is, hey, Google Cloud Platform, hey, can you handle this for me? And it turns around and says, don't worry, I've got this. Yeah? We don't have to worry about back-end infrastructure. It doesn't matter what our scale is. It's going to handle that whole thing for us. So what does that actually look like? So App Engine is one of Google Cloud Platform's primary platform as a service. So what does that really mean? Essentially what that really means is you write your code, it bundles it up for you to deploy it, and it pushes it up into App Engine. And App Engine handles handles those requests, right? Handles taking that code and running it in the cloud for you so you don't have to worry about it. It's generally a web-based application server system, but it works perfectly well for games like we were looking at here. The big takeaway I want you to look at here is that App Engine will auto-scale for you. So it doesn't matter how many requests come in, it'll spin up as many instances of your code as are needed to run it as much requests are coming in. So super, super powerful. At the same time, you don't have to worry about patches or security or any of that sort of really annoying stuff. You just can rely on Google services to do that. On top of that, because it's a platform as a service, it comes with a whole bunch of other services along with it. We're going to talk about two of those services here that are used primarily in War Dragons. One is task queues. Task queues is a service that comes with App Engine to allow you to run background processes. It's pretty powerful. It allows you to back them up and queue them up. You can run them in parallel. It'll have retry mechanisms if that code fails for any reason. As well as that, we'll look at Memcache, which I know you take great advantage of, which is a managed distributed cache system. If you've heard of Memcache, it's been around for a really long time. It's pretty much exactly as expected to be. And there's a variety of other services too, but we're not going to worry about those too much today. On the other side of things, so rather than the request side, but on the data side, we're going to talk about Cloud Datastore as well. Now, the great thing about Cloud Datastore is it does sharding and replication for you. But it's a NoSQL managed data store as well. So it doesn't matter how much data you put inside Cloud Datastore, you don't have to worry about adding like replicas or mirrors or anything like that. And the big takeaway here for this as well is that it doesn't matter how much data there is in Datastore, your read and write times stay the same, which is really, really, really powerful and so important for gameplay and making sure your player experience is great. OK, so we've talked about the products. Great, wonderful. Let's get into the nitty-gritty and actually hear about how all the things that power War Dragons work. So when we got together, we talked about a variety of stuff. We talked about communication over REST. We talked about matchmaking. We talked about leaderboards. Gustavo, you want to take us through some of those things?
Sure. OK, so let's start with REST and JSON. So all of our communication with Google App Engine happens with using REST request with the JSON as the data representation over HTTP. So this is like industry standard, works really well for mobile because it's fast, it's faster to render, it's faster to parse, it's very easy. As I said, industry standard, so Google App Engine handles that really, really well. So that's why we chose to do all of our communication. We have some real-time communication that we do over a service called PubNub, because basically it was a service that had that real time, so we didn't want to rebuild that. But all the rest of the operations that happen in War Dragons, all the reporting and all the analytics that we have and all the relationship between players, all that goes through GAE using REST and JSON all over the HTTP. That is also a great advantage because HTTP works everywhere. On mobile, there's a lot of problems with networks. There's like crazy proxies out there, and you go to a coffee shop, there's another proxy. And if you don't use the HTTP, you're going to have a lot of problems on mobile. If you use HTTP with REST and JSON, it's easy. It works everywhere.
So there's really like no special sauce here. There's nothing particularly crazy going on. It's just basic REST.
Yeah, yeah. The communication is over basic REST. And we can see, oops, sorry.
Nope.
Oops. So we can see here, this is the number of requests that we had, right? This is 24 hours when we launched the game. So you can see the number of requests going up there. A number of errors don't go up, like our error numbers are pretty low, almost zero over there. And again, we didn't have to do anything. We didn't have to like keep an eye out for our servers and see if we're going to start to have like more latency or anything like that. It just works whenever something like that grows. You can see the number of instances that your game has, it's being served by, the number of instances that Google spins up for you, they go up as well, and your time remained constant.
So you didn't have to like re-architect your app as soon as you got really popular or anything like that. It was all pretty much easy enough to scale.
Pretty much easy enough. We had some things that we're going to see later that we faced, but nothing that was like user-facing or that broke the game in any way.
Wonderful. OK, cool. So I know you do some particular interesting things with App Engine and versions. For those of you who aren't aware, one of the nice things about App Engine, because it's platform as a service, we take your code when you deploy it, and we actually deploy it as a version up into the cloud. This actually normally ties directly to a unique URL as well. This is nice for like testing if you're doing, say, smoke testing, but in a web application context, normally you just send it all to a default version, which becomes like your canonical or your production version. But I know, Gustavo, you do actually something really interesting here. Can you explain that?
Yeah. So we do something different with versions. So versions is something that usually people use for testing. So if you're doing a new feature or if you're changing your website, you spin up a different version and you test on that version and your production app is still the same. If you have multiple developers working, every developer can have their own version, so nobody's stepping on anybody's toes. But one of the uses that we got from versions, which is a little bit different, is to so that we are able to break compatibility between our client-side code and our server-side code. So how do we do that? So let's say in this example here, I have my client version 2.07 deployed, and people are using that version. And so for that version, we deploy a version of Google App Engine that is compatible with that. So the Google App Engine version 2.07. As soon as we submit another version of the client code that breaks compatibility, what we do is we deploy another version of Google App Engine that is compatible now with that version. And because the clients, they have different URLs, they each communicate with their own versions. So for a brief period of time, whenever we release a new version, we do have clients playing in two versions of the game. So if we had only one server out there, we would break everyone. We would need to have crazy code that handle, like, if it's this version, do this. If it's this version, do that. And we all know how ugly that can be. With this scheme that we use, we don't have to worry about that. We can just break that compatibility right out, and it all works. So then we have those two versions as people are upgrading. At some point, we force people to upgrade. And then what we do is we basically just take down that 207 version of the game. As we do that, that URL doesn't see that version, so Google just redirects you to the default version, and the default version is always the new one. And then now, all that the client's going to get is that, please upgrade, your game is not compatible anymore, you need a new version. But by that time, everybody can upgrade, and then everybody goes to version 2.10.
Great. So I know matchmaking is an interesting problem. So if you aren't familiar with games, I'm sure many of you are. Matchmaking is basically just trying to take two players from a pool and pair them together so they can have a game together. I know it's an interesting problem because you don't want like drastically outmatched players. You don't want someone to come in and be like completely dominated or to completely dominate another player. You want it to be such that they're at almost similar power levels. So it's very close and they have a really interesting game that way. How do you solve that problem?
So for War Dragons, we have millions of players, and every player is going to have a different level, right? If you just started right now, you only have a few dragons, your base has only a few buildings, but if you've been playing for years, as some of our players have, like, you have a full base. You have a lot of dragons and a lot of very strong dragons that you can battle. So you don't want those two people battling together, because one is just going to crush the other, and the other is not going to win any battles, right? So you don't want that to happen. It's going to frustrate your users. So what we do is we create basically buckets of users. Oops, sorry. We create buckets of users with their power level, basically. So we calculate your power. We put people that have that relative power with the same bucket. And whenever we need to fetch an opponent, whenever a client goes, say, hey, I want to battle someone, we can quickly see what is your bucket. We go to that bucket in Datastore. We fetch any of the opponents that are there. We have all the data that we need is in that bucket in the Datastore, and we serve that to the client. So it's a really efficient way to have people battling, people that have their same power level without having to like do big queries in a Datastore to search for people. So we already do that. We do that in an asynchronous way. So it doesn't take any time for the users. So whenever, let's say, a user does a battle or upgrade a building or get a new dragon, what we do is we add a task to our task queues, and that task queue is going to see, OK, what is your power level now, right? And see if it has to change your bucket. So if it decides that it has to change your bucket, it simply takes you out of one bucket, puts you in another bucket, and now when you battle for the next time, it simply picks you out of your next bucket. So really simple solution to something that would be really, really complex in a normal database system, right? So using a Datastore and task queues, this became really simple for us, very easy and fast for the end user as well.
Cool. So I know you also do special events on occasion within your world. I know you do a Conquer the World map where you have guilds of players to fight against each other. Tell us about what happens there. I know you have to render a world map so all the people in the game can see what's going on. What sort of problems are you solving there?
Sure. So Conquer the World was an event that we had for a weekend where guilds, which are groups of players that band together to serve as allies, the guilds would start, everyone with their own territory in a map such as this, and throughout the weekend you would battle your opponents and gain or lose territory. And so the goal was to have as much territory as you have. This is what happened during that weekend. So you can see all the players, all the guilds expanding and contracting. Like there was a lot of strategy involved there. People were like trying to save their dragons to the end so they can conquer more. So you see the green team and the yellow team.
I see the orange team seems to be doing very, very well.
The orange team, yeah, and the green team. That was the final result of that weekend for one of our divisions, right? So what we wanted is we didn't want just to have something where you know a number. You have like how many square feet you have of territory. We wanted users to have a map, to have that sense that they are attacking and gaining territory. So doing that on the client side would be extremely difficult for us. So we decided to do that on the server side. So on the server side, what happened was we have task queues going in periodically. We're doing that every 5 minutes. So every 5 minutes, those task queues would grab every data from every battle that everybody fought during those 5 minutes, recalculate territories, and actually generate that image. So this is for every division. Division is a collection of guilds, which is kind of like matchmaking for guilds, for that level of guilds. Right, so you can see there we have those guilds, which are actual real names of guilds that we of divisions that we have, and every task queue is calculating that. One of the things that we did here, which is a little bit different than what task queues do. Task queues, whenever you add something to a task queue, if you add 100 things to a task queue, Google App Engine is going to try to run that as fast as possible. Right? So if you have 100, if you have like 2 servers, it's going to try to spin a bunch of servers, execute that. When you don't have anything, it takes down your server. So this would be something, what you would see if we had those task queues running with what is called the default scaling. So every 5 minutes, you would see a spike in the number of servers that Google's spinning up for you. Then it spins down, you go almost to 0, and then 5 minutes later, you're spinning up a bunch of things, right? So this is very inefficient from a computing standpoint and from a cost perspective too. So for this case, because we knew the number of divisions that we had, like the number of divisions doesn't change during a weekend, we change that on a periodic basis, but we know it's not going to change during the event, right? And we know we want to render that every 5 minutes, and we know rendering takes an X amount of seconds. What we do is we use basic scaling. So basic scaling, you say, don't spin more than X number of servers for me. So when you do that, then you see something more like that. So you still add 100, 200 tasks in your task queue, but Google's not going to spin up more servers. It might spin up one, maybe not, but you're going to see something way more constant, which is great for your cost, and is also great for your computing because computers don't have to start and stop all the time. So this is one of the things that we did differently than the default scaling that everybody uses out there.
So this was really cool because you knew exactly how many divisions you had, and you knew that wasn't going to change. You were able to take advantage of that to get more efficiency out of your system.
Yeah, whenever you have that fixed computing power that you know that's what you need, using basic it's a better use of your computing power.
Cool. Did I go forward? I believe you also used memcache and some other things as well in that aspect?
So yeah, that was some other improvements that we did to Conquer the World map using some of the Google App Engine features. So we used memcache to cache the metadata. So we had some metadata, like for example, where's your capital? So the client would render the name of the guild inside of the map. So we had to have where is that going to be rendered on the client side. So we had some metadata, and we had memcache to cache that, because it's really fast for the client to grab that information. We also use something called Google Edge Cache, which it's basically a caching of your information. So whenever we generate that image, Google asks us for that image. We say this image can be cached for 5 minutes. So then we don't use that computing power anymore. Google Edge Cache just takes care. It knows that that image can be stored for 5 minutes, and it just serves that. So it's something that also saves us money and makes it way faster for the client to get that image, because you don't have to hit a computer to grab that image and return that for you. It returns from Edge Cache almost immediately.
Excellent. So I know you also have a leaderboard system, so players can rank themselves or be ranked within a whole subset of all the players. I know that's kind of an interesting problem. Do you want to sort of describe the problem?
So yeah, leaderboards are an interesting problem. They seem simple in the beginning, but then you start to see that it's more complicated than it seems. So leaderboards, they basically need to answer those 3 questions for you in a very efficient way, right? So when a leaderboard, I need to know what is my position in a leaderboard. It needs to answer that fast. Then it needs to answer what are the people that are around me, so I can see like people that I want to attack later, so I can jump up on the leaderboards. And it also needs to answer like who are the people that are in position 100 to 120. If our users are paginating, or if they're scrolling, you need to grab more data. You need to be able to grab positions 100 to 120 really fast, right? So it seems easy, right? But as you guys are going to see, databases are not really suited to answer those questions. So let's see a little bit why, right? So this is an example. This was one of the leaderboards that we had a few days ago that I grabbed. So let's say that you have this database. You say, OK, that's easy. I'm just going to create a database with player name and score. I create indices for the player name and the score, so it's easy for me to say, OK, I want to see the Messi, or I don't know how that's pronounced. I don't know why I chose that name. There are better names for me to choose, but well, it's OK. So that Messi guy there, you want to know its position. It's easy for you to check Messi. But it's not easy to know the position, right? Because databases, they basically have to count everybody that comes before that person to know the position. There's no position there. So then you say, easy, just add a position there. Why not, right? So you add a column for position, and now you know, oh, Messi is number 9. Easy, problem solved. Not so much, because what happens when Messi wins a battle and jumps up on the leaderboard? Now you have this weird thing here where Messi is actually number 4, but the position says number 9, because the whole record moves up, right? You can't move partially. So now you have to, you imagine already what you have to do here. You have to go and change a bunch of those records. You have to change all the records between 4 and 9 there, right? And that's a very costly thing. Like, you're changing a bunch of records that potentially other people are changing. So it's not an easy problem. It's not as easy as it looks. So when we started building War Dragons, we started looking for solutions. We were like, OK, people had that problem before. Games have been out there. Competitions have been out there. People had that problem before. And lo and behold, we found some project that Google did for Google Code Jam. Because Google Code Jam is a competition of code. They had a leaderboard of sorts. And they released that project as open source for Google App Engine, because that's how they run Google Code Jam, of course. So Mark, why don't you explain to us how that solved our problem?
Certainly. So I had a look at this code, and I'm going to explain it fairly simply. There is a link to the blog post, which has a link to the code. So if you want to go deeper into it, you're more than happy to. Essentially, what it does is it uses Datastore to build a data structure inside it that's able to answer these sort of leaderboard questions very simply. What it actually builds is a tree. So the first thing you do when using this code is you select your range of what your score could be. Here I've selected an arbitrary range of 0 to 10,000, as that's what my score is going to land into. Then inside that tree, we're going to pick essentially an arbitrary number of nodes underneath it. Here we're going to just use 3 for simplicity. And we're going to split up those ranges into each of those thirds. So you can see 0 to like 3,000, 3,000 to 6,000, so on and so forth. And then so on and so forth down the tree as we go. And that's great. And then what happens is when we have a score come in, so someone gets their score set, it goes in the tree in that range that they fit. That's cool. But what we actually do at each node is we count up how many scores we have for each of the children in a parent node. So if we had 100 scores, it would look something like this. At the top, we have 50, 25, 25. If we continue down the left, we would add up all of those to then 50, so 10, 25, 15, so on and so forth down the tree. This is actually really powerful for leaderboards. If we want to ask questions like, hey, how many scores do I have in total? All I need to do is count up the number of children that I would have in the top node, and that would be 100. If I want to do something like, hey, I want to go find the top 10 scores, all I need to do is go down the left side of my tree until I've counted up till I have 10 results. If I had a score that was 2,222 and I wanted to know what position that was, I could just count to the left of that tree and potentially upward depending on my position as well. So I can answer these sort of questions really easily using this data structure. But like I said, the notes for this and the URL for this are all at the very end of the talk. So if you want to dig into this further, this is a very simple explanation of how it works. But it does solve this sort of problem. And I believe it also, I believe also App Engine for you, you use it development, you use it in a whole bunch of other ways, you love it that much. Tell us about that.
So yeah, so one of the things that we do that is the classic way of using versioning, we use versioning a lot to develop new features. So whenever a developer needs to develop something else, every developer has their own version of the server running out there. It's really easy to deploy. There's a desktop app, press a button, it deploys that for you. And then you can test your features there, and whenever that feature is properly approved, you can then put it on master, and then we have a process that deploys that to our production servers all the time. So every developer has their own, nobody steps on anybody's toes. Classical use of that, we do that all the time. Another thing that we do a lot is we like GAE so much, and it's so easy to develop for that, that we do our own internal tools for that using Google App Engine. So at some point, War Dragons grew a lot. It was our largest team to date. We had like more engineers than any other team at Pocket Jam had before. So we needed to step up our game in code reviews and making sure that our quality of code was good. And we didn't have any tools out there that would serve us the way we wanted to. So we just rolled our own. Like one of our developers worked for a little bit less than a week, wrote a code review portal for us that now we use all the time. The whole company now uses that code review portal. We started adding a lot of process, and we all know that developers hate process. So what I did was I built a robot using Google App Engine that just goes and does the process for us. We don't have to care about that. We just do a few things on GitHub or on our ticketing system, and the robot does all the process things for us. So I just wrote that in a few days, rolled up a new server. It's there. We have a new server running. Really, really easy. We use that all the time for our development tools as well.
Excellent. So you love it so much for building your production apps, you use it internally as well.
I even have some of my own. Like I like it so much that I started, I can do that for my own servers. I was building some little electronics thing, and I needed a server to serve information. I was like, I'll just do it in Google App Engine. It's free for very small use, so I just rolled my own and deployed there on my personal account.
Cool. OK. So it can't all be sugar and spice. There had to have been some challenges, some problems. We should probably have a look at those and see possibly what dragons you had to slay. Terrible joke. Let's have a look at some of that, and so people here can learn from the lessons that you learned while you were building War Dragons.
Sure. So one of the problems that we faced is that War Dragons generate a lot of what we call events. So events are various things that happen inside the game that we can be interested in to know how people are using the game, what time of the day people play more. So there are a lot of things that happen in the game that we save as events, and then we send that to our servers so we can analyze that data later. But as you can imagine, we have like millions and millions of lines of events coming in all the time from our users. And the way that the data store costs are made, you are charged by operations in your data store. So if you're saving one event in your data store, that is one operation. If you're saving 100 events in the same table in the data store, that is also one event, right? So we needed to figure out a way that we could save money on that. Like instead of like getting information from a user, we have 100 events there and doing 100 operations because they all go to different tables. We needed to figure out a way to do that. I'm sorry, Mark, but to reduce a little bit of our cost. So let me tell you how we did that using GAE's own infrastructure. So what we did was we used memcache for this, because memcache is really well suited for this problem. It's very fast. So what we did was basically we create a bunch of records in our memcache that receive the events from the players. So these particular records in the data store, they just accumulate a bunch of events of different types. They don't care. They just start to get that information there. At some point, memcache has a size limit. So at some point, you reach that limit. When we reach that limit, what we do is we fire up a task queue. That task queue now grabs all the events from that particular record that is full, and it starts to sort into a second level of records in memcache, which are in this case particular to every event. So if it's event type A, goes to that record. If it's an event type B, goes to that record, and so on and so forth. And when that record is emptied, it can be reused by other clients. At the same time, those other second level records are also going to become full. When they become full, we fire off another task in the task queue, and now they put that into the data store. So now we turn what could be hundreds, thousands of events, that could be thousands of operations. Now they do only one operation because now they're sorted by their table, and they go straight to that table. And then they can be reused for another operation. But with that, like, we were able to reduce millions and millions of operations to a few operations per minute.
Excellent. So you're able to use memcache to really make that an efficient and faster process. And as we've seen before, you're using memcache all over the place as well.
Yeah.
Great. So one other issue I know you faced is Datastore data contention issues. For those who aren't familiar, one of the issues with Datastore, or possibly one of the challenges with Datastore, is there are some hard limits around how fast you can write or change data on a single entity. So if you have two processes operating on a single entity within Datastore at a given point in time, it can turn around and be like, whoa, slow down, I'd like you to stop hitting me so fast. I know that was a problem for you. You want to talk about that and how you ended up solving it?
So yeah, data contention was a problem for us. So you can imagine that we have some operations that touch a lot of things. So I'm going to give the example of battle reports. So whenever you finish off a battle, you send that battle report to our servers, and our servers need to do a lot of stuff. So it needs to award the loot that you got from that battle. At the same time, it needs to remove resources from your opponent's record. It needs to award you medals so you can go up on the leaderboards. So all that touches one record, touches two records actually in the players. You have to actually add to the war results. If that battle is part of a war, you have to go and add the war results. You have to change your leaderboards. You have to change your matchmaking bucket. And then, after you did all that, now you respond to the user. So we have one problem is there's a lot of time that the user is not getting a response, and maybe your game is waiting on a waiting screen, so that's not good user experience. And the other problem is that with this, you imagine with millions of users doing that, a lot of them might be hitting the same record. So if two people from the same guild are battling in a war, they're all going to hit the same war record, right? And when that happens, you get data contention. One client needs to wait for the other one to finish. And if they wait too long, this operation is going to fail completely, right? So not a good solution. So what we did was, again, using all the resources for Google App Engine, we broke that down. So what we did was we do the least amount of possible work that we need to give a response to the user. So the user at this point only needs to know how much loot it got from that battle. That's it. So we do that. And then we add a task to what's called a transactional task. It's kind of a task queue, but has special properties, which is really nice. We, at that point, the award loop just goes to one record over there. Then we return to the user, so really fast. And then we add a task to the task queue. That task is going to do all those things that we were doing before. So it's still going to remove resources. It's still going to give you medals. It's still going to add to the war result. It's still going to change leaderboards. You're going to change your matchmaking bucket, all of that. And then you're going to ask, but can't that run into data contention as well? You're doing a lot of stuff into one operation. And yes, you are right. Thank you. You're a very smart audience here. So that happens. But when that happens, it's an awesome feature of task queues is that they just retry. So if there's any data contention there and your operation fails, this just goes back to the queue, and after a while, it just retries. So when it retries, at some point, it's not going to face data contention, and at some point, it will commit all that. Takes a while, but it doesn't change the experience in any way for our players. Those operations don't change anything in a meaningful way for our players, so they can be done asynchronously, they can take a while, they can be retried. So that's a really, really nice feature of task queues.
Excellent. So you're able to take advantage of the fact that you have a lot of control over how task queues can retry, exponential backoff, number of retries, number of days, et cetera, and so you can make sure that this always happens. It's just a question of how long.
Task queues are awesome. Like if you have a bug in your code, you can just change that code and redeploy all your operations that failed, rerun on that new code. So you can fix code on the fly, and you can see the sizes of your queues. It's amazing. It's really awesome. We have some queues from our old games there. Just a fun fact, we have tasks that have been running for 2 or 3 years because we have buggy code there, and because it's an old game, we don't care. We just let those things run there, and they've been running for like 3, 4 years. We have old tasks like that. It's relentless.
Fine, cool. All right, so I'm sure your code is perfect. Mine often has some issues. I know App Engine gives you log aggregation by default, but how do you use that? I know you've got some nice ways that you use that within War Dragons.
Yeah, so the log aggregation that we get out of the box, it's really useful. It's really easy to use. So this is just the default console log that you can access for Google App Engine. And you have a search box over there at the top that you can just search for anything in your request or in your headers. So in our case, for example, we use that a lot to track down problems that users are having. Every user has a unique ID, which is a hash-like ID that is really easy to search for because you're never going to find another one in your request. So whenever we need to know what requests are failing for a certain user, we just go there, we search for their ID, it comes up with all the results, and then we can dig in. We can go in and see the metadata, the proto payload. We can see all the GET requests parameters. We can also see, you can add logging statements to your code, and they will also appear here as the logging statements. If there was an exception in your code, you're going to see that exception. So it's really, really easy to use tool that we use all the time that is right out of the box. We didn't have to do anything to get this.
Wonderful. All right, great. So we've been talking today about running games at scale, but really what we're talking about here is running games at scale without having to manage your back end. We've looked at 2 special products here, App Engine for scaling our requests and auto-scaling those responses. And also we've been looking at Datastore. We've been looking at managing our scale of data using Datastore. But please remember, these are just 2 products that exist within Google Cloud Platform that can help you build games. We certainly have a huge slew of products that will help you build games as well as a variety of other applications. We definitely have a huge number of other sessions still here at GCP Next. So if this stuff is interesting to you, please make sure you check out all of them. Finally, I'd like to say thank you very much to you, Gustavo. I appreciate you coming.
Thanks for having me.
If people want to learn more about War Dragons or Pocket Gems, I know you're coming out with a new version soon. Where can they go?
Oh yeah, I forgot to ask one thing, like who here has played War Dragons before? All right, so we have some people, so hopefully that's going to change right now. So if you guys want to play War Dragons, you can just go to wardragons.com. Awesome website, there's a lot of resources out there. If you want to learn more about Pocket Gems, just go to pocketgems.com. If you're an engineer or a product manager or a game designer or an artist, come talk to me, go to our website. We are hiring, so come talk to me. I'll hang out a little bit more outside.
Excellent. And if you're interested in App Engine or Datastore, the URLs are up there, along with the link to the global game jam or global code jam code that is there in the URL right there. And thank you very much to you all for listening to us. We really appreciate it. Thank you so much.